Hi everyone, welcome back. We are continuing in Module 2. We're in Topic 1, Lesson 3, Activity 3, and we're on page 200. Rates and proportions. You just use tape diagrams as a visual representation to solve ratio problems. What other strategies can you use? Coach Roberts wants to encourage her swim team to increase their speed. She will give an award to the member of the swim team who can swim the most laps in 20 minutes after practice this week. The table records the results from this week's practice. So we have the student name, Kay, Susan, Doug, Mako, the number of laps in a specified time. So Kay does 4 laps in 5 minutes, Susan 7 laps in 10, Doug 1 lap in 2, and Mako 3 laps in 4 minutes. I love that they gave this person a shark name. The Mako shark is one of my daughter's favorite sharks. Okay, explain how Tia's reasoning and Lisa's reasoning about who will win the award are incorrect. So we have a thumbs down on both. Tia says Susan will definitely win the award because she swam the most laps. And she did. She had 7. Lisa says it took Susan the longest time to swim her laps. She will not win the award. So Tia saying Susan definitely wins because she swam more laps. Lisa says she definitely won't win because she took the longest time. So what's wrong with their reasoning? Pause the video, think about it, write something down. Okay, hopefully you did that. So what's wrong with their reasoning? Well, each girl, Tia and Lisa, only looked at one part of the ratio. You can't, oops, sorry, ratio, not ration. That's a period. Ah, it's terrible. Let's just rewrite that. Ratio, right? You can't look at just the number of laps or just the time. You have to look at the entire thing. Each quantity in the table is a rate. Underline, highlight, whatever you have. A rate is a ratio that compares two quantities measured in different units. The rate for each student in this situation is the number of laps per amount of time. So laps per amount of time. So we're going to be talking about laps. Remember the fraction bar, you say per the amount of time. Per also means for every or for each. So for example, Susan swims 7 laps for every 10 minutes or for each 10 minutes per 10 minutes. Okay, moving on. 201. K's rate is 4 laps per 5 minutes. You can write this as, sorry about that, 4 laps per 5 minutes. Write the rates for the other 3 team members. So Susan, I guess we got to look back at that. Susan, we just did. So hers is 7 laps per 10 minutes. And what's Doug's? Doug's is 1 lap per, right, 2 minutes. And Mako's is 3 laps per 4 minutes. Okay. Take note, it's important to line up the units when writing equal ratios. So whenever we're talking here, we're going to have laps in the numerator, minutes in the denominator. That's what it means to line them up. When 2 ratios or rates are equivalent to each other, you can write them as a proportion. A proportion is an equation that states that 2 ratios are equal. In a proportion, the quantities composing each part of the ratio have the same multiplicative relationship between them. Okay, so let's highlight some things. So a proportion, or underline it, is an equation that states that two ratios are equal. In a proportion, the quantities composing each part of the ratio have the same multiplicative relationship between them. For example, you know that Kay swam 4 laps per 5 minutes, so you can predict how many laps she could swim in 20 minutes. So they're showing this a worked example. So 4 laps, 5 minutes. Notice they have the labels over here so that they're not writing it each time. Notice there's an equal sign here, which it says a proportion is an equation. The equation means there's an equal sign. And then we have the 16 over 20. It's multiplicative because we go from 5 to 20 by multiplying by 4. So we're going to go from 4 to 16 by multiplying by 4. You can actually see that really well in front of me, and it looks terrible on the camera. So that's a times 4, which means it's multiplicative. Kay can probably swim 16 laps in 20 minutes. Doesn't guarantee it. Something might happen, like, I don't know, she might get a mouthful of water and start choking and have to stop, or, anything could happen. When you change one ratio to an equivalent ratio with larger numbers, you're scaling up the ratio. So when you change one ratio to another with larger numbers, you're scaling up. Scaling up means you multiply both parts of the ratio by the same factor, which is going to be greater than 1. Okay, page 202, last page of this activity. Why is it so blurry? Remember, one way to represent a ratio is in fractional form. It doesn't matter which quantity it is in the numerator or denominator. It does matter that the unit of measure is consistent among them. So here they're showing minutes over laps. So in 5 minutes, they go 4 laps. Remember, this is the same strategy used in elementary school to write equivalent fractions. That means last year in 5th grade. Okay, because they actually consider you guys in middle school for this textbook series. Isn't that pretty cool? All right. Determine the number of laps each student can probably complete in 20 minutes. Explain the scaling up you use to determine the equivalent ratio. You can just show it. If you can just show me the number that you used for the scaling up, then I will be good with that as your explanation. So for Susan, let's see. So this is this was Kay the 4 laps in 5 minutes? Let's just look back. Kay was 4 laps in 5 minutes. So this is Kay's. Okay. So Susan was 7 laps in 10 minutes. So they're going to do this minutes over laps here. So we'll do that. Minutes over laps. So she had 10 minutes, 7 laps, and they want to know 20 minutes. So 20 minutes. So how do you go from 10 to 20? Right, multiply by 2. So if in 10 minutes she does 7, 20 minutes, we would expect her to do 14 laps. Okay, what about Doug's? So so again, we're keeping with this same setup, minutes over lap. Minutes was 2 for every 1 lap, and we're looking for 20 minutes. So how do you go from 2 to 20? We are scaling up by 10. So here we're going to scale up by 10. So 1 times 10 is, right, 10. So we would expect 10 laps in 20 minutes. Remember, K's is 16 laps. Okay, and then finally, Mako was 3 laps in 4 minutes. So minutes 4, laps 3. And we want a total of 20 minutes. So how do we go from 4 to 20? We're increasing, so we're scaling up by 5 times. So 3 times 5 gives us, right, 15. So 15 laps. So then it says, number 4, which team member is the fastest and who do you think will win the award? So who can swim the most laps in 20 minutes? So we have Kay at 16, Susan at 10, Susan at 14, Doug at 10, Mako at 15. So that would be Kay is the fastest. Since she can probably swim 16 laps in 20 minutes, which is more than each of the other team members. Okay. And there you go. Go ahead and pause and get that written down, and we will see you on the next video.